Thank you so much for coming here today. So, my name is Antonia Forster. My pronouns are she, her, and I'm the Senior XR Technical Specialist here at Unity. XR means extended realities, and it's an umbrella term that covers AR, augmented reality, and VR, virtual reality. So, I specialize in using these technologies to blend real and digital content together to change different industries, and also creating educational and inspirational content to empower you to do the same thing. So you can actually create augmented reality content, which is where you see the real world with virtual content augmented on top, for headsets, which have transparent displays, or for mobile devices like tablets and phones. Because not many people actually have an AR headset, today I'm just going to focus on AR for mobile devices, and in particular, how they can be used to do good in the world, whether that's social impact, education, awareness, or environmental impact. This tech can and is already changing the world in a myriad of different ways. Today, I'll show you how, and also how you can join in and create your own AR application. So here's how the talk will be structured today. First, I want to show you how some amazing creators are using Unity to create augmented reality apps that are making a positive difference. Everything from Black history to queer representation to conservation and mental health. Then I want to show you how these kinds of applications are made. And don't worry if you've never used Unity before, or if you have no coding experience or no background in augmented reality. That's completely fine. I'll show you exactly what the Unity editor is and our two main solutions that you can use to create augmented reality content. We'll see AR Foundation in detail, and I'll walk you through a tutorial end to end of how you can create your first AR app. And then we'll briefly touch on Mars and some of the features it has. And then I'll leave you with some links at the end to continue your learning journey. So this is a sneak preview of what you'll be able to make by the end of this talk. You'll be able to make a virtual character or a 3D model appear on a real life image marker, like a poster, a book, or any printed image that you like. I'm using this robot character, which is made by Unity, and that's freely available for you to use, but you don't have to use this 3D model. You can make anything appear on top of your image. It could be your own artwork, or some text, or any kind of 3D character or model. And I'll also show you where you can find 3D models and characters to use. So if you've been to some of the other talks here at the Unity for Humanity Summit, you may have seen that Unity develops a lot of different tools. But this is a Unity editor. This sits at the core of it all. The Unity editor is a real-time 3D development platform. So it's basically a sandbox which you can use to create any kind of content that you want, whether you're an artist, an activist, a games developer, or an engineer. You can use Unity to build content for a traditional monitor, or for a mobile device, or AR and VR content. And if you've never created AR or VR content before, then don't worry, because building those kinds of experiences is not very different to building anything else in Unity. In fact, if you have existing assets or characters or environments, you can bring these into augmented reality with just a few clicks. For that reason, Unity is one of the most popular choices for building augmented reality content. 60% of AR and VR content is made using Unity, and mobile apps are particularly popular. There are 5 billion downloads every month of apps that are made with Unity. So even if you've never used the Unity editor yourself, it's very likely that you have used an app that was built with Unity. So what does this content look like? How can AR be used to make a positive difference in the world? Well, one way we can do this is through interactive storytelling and diverse representation. The Twisted Tales are a series of illustrated storybooks that interact with your mobile phone. The writing and the illustrations for every story blend with virtual content to bring it to life, using AR technology for play and for education. The stories themselves are lessons in empathy, love, and understanding. They teach kids and adults social values and skills, and the importance of accepting the different into our lives. Comic books, too, are embracing this technology. Island Fever is a series of comic books that follows a group of kids as they navigate a scary world in search of good memories. The overarching message of the series is to represent children of color in a realistic struggle, aspiring to greatness despite the adversity that life presents them. Again, you can point your mobile device at the book, and AR brings the characters to life. It triggers animations and even allows you to interact with the characters and take pictures with them. The goal of Island Fever is to promote life, liberty, and the pursuit of happiness. AR can also help with mental health. Helium is an application that allows you to see your feelings or your mood states. It picks up on physical cues and biometric data, your heart rate and your brain waves, using wearable devices like a smartwatch. And these are displayed as butterflies, abstract art, or planets, reacting to your body's physical cues. You can control your environment with your thoughts. So, in a very literal way, your body and your thoughts have power. AR can also be used to build virtual museums. Black Terminus is a tool that builds virtual open-air museums and walking tours of Black neighborhoods. It allows artists, museums, and storytellers to bring Black history to life in a new way by using Black archives, artworks, and artifacts combined with this immersive experience. You can literally see history play out in the setting around you. Along the same lines, the Monuments Project, or Kinfolk, is a catalogue of AR monuments of women, people of colour, and LGBTQIA+ icons. This allows marginalised people to see themselves in their history. They also partnered with Langston League, who specialise in teaching educators how to create culturally responsive material that is inclusive for all students. Another beautiful example of AR being used for something really completely new is Breonna's Garden. This was created in solidarity with Breonna Taylor's family. Breonna's Garden is a virtual sacred space, brimming with art, life, and beauty. It's a space to honour Breonna Taylor, but it's also a refuge where you can give yourself a moment to rest, to surrender, feel at peace, and maybe also to celebrate someone that you miss. AR is a very popular tool in classrooms for education because it's a great way at engaging students. Victory XR is just one example. Using a smartphone, you can look and walk around an entire virtual classroom as if you're really there. You can learn about biology, astronomy, history, and more. It also allows students and teachers to interact in the virtual environment. And finally, AR can be used for conservation and environmental impact. BBC, Kew Gardens, EE, and Dimension Studios all teamed up to create a 5G AR experience inspired by the BBC show Green Planet. The TV show will be presented by Sir David Attenborough, and the app will be designed to encourage audiences to discover new and surprising wonders of the natural world by blending entertainment and education together. So AR is already changing the world, from teaching Black history and representation to LGBTQIA+ inclusion, to disability awareness, to environmental action. So if you can learn to develop AR applications, even technically very simple ones, you can use it for storytelling, education, art, or activism. But where do you begin? One of the challenges of AR is that there's many different tools available, both hardware and software. For example, if you're developing an app for mobile phones, you don't know which mobile phone your user has. Different devices have different capabilities, and historically, you would have needed to develop your app specifically for one device. For example, if you want to build something for an Android phone, you would have had to use AR Core, which is Google's AR SDK, or Software Developer Kit, for mobile. If you wanted to build for an Apple device, like an iPhone or iPad, you would have instead have had to use ARKit, which is Apple's SDK. So wouldn't it be great to build once and deploy to many mobile devices? That's where AR Foundation comes in, which is Unity's solution. It doesn't implement any extra features itself. Instead, it's a layer that sits between the Unity editor, which you use to create your app, and then specific softwares for specific mobile devices, like ARKit and AR Core. That means when you build something in AR Foundation, you can create it once and deploy it to whichever mobile device you want. Any features available in AR Core or ARKit are also available in AR Foundation. So for example, in ARKit, you can utilize people occlusion. When people walk in front of virtual content, they occlude it so it seems as if it's in the real world. Body tracking, collaborative sessions, and much more. AR Foundation is available via the package manager, which we'll see in a moment, and is completely free. These are the kind of things you can make using AR Foundation. Face tracking, spawning virtual objects onto a horizontal plane, maybe spawning furniture onto the floor within your home, or spawning animated characters onto an image marker. These first two examples have full tutorials available completely for free on our platform Unity Learn, and I'll give you the link to those at the end of the talk. This final example we'll see how to make right now. So we've covered what AR Foundation is, what it can be used for, and we've seen how people are using it to change the world. So the next question is, how do I get started making my own AR application? Well, without any further ado, I want to walk you through it. Again, don't worry if you have no technical experience at all. This is for complete beginners, and you won't need to do any coding. I might go a bit quickly because I only have limited time here with you today, but if you do find it too quick, don't worry, you can follow along with the recording of the talk and pause it whenever you need time to go through the right motions. So, the very first thing you need to do is download the Unity Hub, which is completely free. To do this, browse to unity3d.com/get-unity/download, or it's easier to just search for Unity Hub on Google and it will be the first result. Then download and install the Unity Hub. Once you have it installed, open it up and it will look something like this. I have lots of existing projects, but if this is your first time using Unity, you won't, so it might look a bit different. To install the Unity editor, the main piece of software we're going to use, click on the Installs tab on the left-hand side. Then click on Add in the top right and select which version of Unity you want. For this project, I'm using Unity 2020.2.7F1. If you can't see the version of Unity you want, then click on Download Archive, which will take you to a web page. Then find the version of Unity you want, click on the Unity Hub button next to it, and it will open up back in the hub. Then it will ask you about build modules. These are used to put your finished app on the mobile device. So if you want to put your app on an Android phone, tick the box for Android build support. And if you want to put your app on an iPad or an iPhone, tick the box for iOS build support. It's fine to tick both if you want to. This is an important note though, in order to deploy to an iPad or an iPhone, you will need a Mac computer. Then click on Install and wait for it to finish. Then to start your new project, open up the Unity Hub and click on this drop-down arrow next to New and choose your desired version of Unity. We'll use 2020.2.7. Choose a name and location for your project. Once that's done, click on Window, Package Manager. Click here to make sure you're searching for all packages in the Unity registry, and then download the AR Foundation package. Also search for the XR plugin management package and make sure that's installed too. And finally, if you're developing for Android, search for and install the package called AR Core. If you're developing for an iPhone or iPad, install the package called AR Kit. Now we have all the packages we need, we're going to create an AR session. To do this, right-click in the window over here, the hierarchy, then go to XR AR Session. Do exactly the same again, but this time create an AR Session origin. Because the AR Session origin already has a camera in it, it means we can delete the main camera. Now click on AR Camera, and in this window, the inspector, set the tag here to Main Camera. We're going to create an AR app that spawns a character in our environment. So to find a character, click on Window and Asset Store. This will open up in your browser. The Asset Store is full of content that you can use. You can browse by keyword, type of asset, or by price. I'm going to search for Kyle and then download this character called Robot Kyle. Click on Download and then Open in Unity, and then Import. Now we have our character, so we can find it in the project window, this window down here. This one is in Assets, Robot Kyle, Model. Drag and drop this into the hierarchy and double click on it to focus. If you want to move around the view in this main window, you can hold the middle mouse button to pan, hold down right mouse button to look around, and zoom in and out with the scroll wheel. You can click this gizmo button to toggle symbols on and off. Now this robot is quite big. 1 in Unity is 1 meter in real life. So let's set the scale to 0.1 in every dimension. So it will be 10 centimeters big instead. And that's it. You're actually done making your first AR app. It's a really simple app. we haven't set up anything to tell the character where to spawn. It's just going to generate in the location of the mobile when it first launches the app. But it does actually work. So to test it, we have to put it on our mobile device. I'll first show you how to build for Android, and then I'll show you all the steps for building for an iOS device. So first click on File and Build Settings, and click the Android tab here. Press Add Open Scenes and then switch platform. If your Android device is plugged into your computer, it should appear in this drop-down menu, so select it, or just leave it as default device. And now click on Player Settings. Under XR Plugin Management, which is here on the left-hand side, ensure the Android tab is selected and Initialize XR and Startup and AR Core are both ticked. Then under Player, scroll down and tick the setting called Auto Graphics API. Scroll down further to find Minimum API Level and set it to API Level 24. Set your scripting backend to IL2 CPP, and then where it says Target Architecture, untick ARM7 and tick ARM64. I know that's a lot of settings, and you don't need to know what they all mean right now, especially if you're a beginner. Those are just the settings we need to put our app onto our Android phone. We're now ready to send our app to our phone, but to stop it from being blocked, we need to make some changes to the settings. On my phone, the Pixel 3a, these can be found in Settings, About Phone, scroll all the way to the bottom, and then tap on Build Number about 7 times. This will unlock developer options on your phone. You can then find these in Settings, System, Advanced, Developer Options. Scroll down and switch on USB debugging to allow your app onto your device. Now, back in Unity, we just have to click on Build and Run. Name your app whatever you'd like and click Save. When your app finishes building, it will automatically launch on your phone. Now, before I show you what it looks like on your phone, I'm going to walk through all of the iPhone, iPad, and Mac users. To deploy to an iPhone or iPad, the steps are slightly different. To do this, you're going to need a Mac. You also need to install a program called Xcode onto your Mac. This is a Mac-specific program for handling code, and it will allow you to push your app onto your device. You can find it and install it using the App Store. Then go ahead and do all of the previous steps that we did before. Download the Unity Hub, download Unity 2020.2.7, and when you do that, remember to tick the box for iOS build support. Also, remember when installing packages, you'll need the same ones as before, AR Foundation and XR Plugin Management, but also the AR Kit package. Then in Unity, go ahead and build the app, just like I showed you before. Once you've created your app, we want to adjust the build settings to deploy not to an Android, but to an iOS device. To do this, click on File, then Build Settings, and this time choose the iOS tab from the left-hand side. Click Add Open Scenes, and then switch platform. Now head over to Player Settings. Click Player on the left-hand side, scroll down until you find Requires ARKit Support and tick that, and make sure that target minimum iOS version is set to 11.0. Next, click on XR Plugin Management on the left, click the iOS tab, and make sure Initialize XR and Startup and ARKit are ticked. Now back in the Build Settings menu, click Build and Run. Choose a location to save your app to. This has to be a completely empty folder. Click Choose and wait for the build to complete. When it's done, it should open up in Xcode. If it doesn't automatically open, just use the Finder to browse to the folder you created and double-click the .xcode proj file to open it in Xcode. Now click on Unity/iPhone in the top left. In order to build the app, we have to hook up our Apple ID to Xcode. To do this, click Xcode on the very top toolbar, then Preferences, Accounts, the Accounts tab here. There we go. If you don't see your Apple ID in here, you can use the plus sign to add it to your account. If you don't have an Apple ID and you need some guidance about how to get one, or you need more information about installing Xcode or adding your Apple ID to Xcode, then browse to docs.unity3d.com/manual/iPhone account-setup.html, and then click on the relevant link there for more help. Next, close out of this window, and then click on Unity-iPhone again in the top left. Now click on the Signing and Capabilities tab, and tick Automatically Manage Signing, and then Enable Automatic. Now click on the Team drop-down, and choose your team or your name. Now, optionally, if you want to, click on the General tab, and give the app any display name that you want, as well as a unique identifier. Then ensure your iPad or iPhone is plugged into your Mac. Click here on any iOS device and set it to iPad. We're very nearly ready to deploy to our iPad or iPhone, but just like the Android users, we now need to change the device's settings so that it won't block our app. This is very easy on your iPad or iPhone. Just click on Settings, Device Management, Apple Development, and click Trust Developer, and then Trust. Now our iOS device will trust the app and won't block it. Now just ensure that your iPhone or iPad is plugged into the Mac. Then next to Unity-iPhone at the top of the Xcode window, select iPad or iPhone, whatever your device is, and then click the play button and wait for the app to build. Whether you're using an iOS device or an Android phone, this is what your app will look like. It's the simplest possible AR app. The asset is floating in space because we haven't added any way to anchor it to the real world. It doesn't appear on an image marker or a horizontal surface. The starting position is actually determined by where the mobile phone or tablet is when the app launches. So let's jump back into Unity and add a system to make our characters spawn on an image marker instead. To do that, select AR Session Origin, click Add Component, and search for AR Tracked Image Manager. This has 3 fields. The reference library is the library of images that will act as markers or anchors in the real world. Don't worry about this middle field just yet. Then tracked image prefab is the virtual character or model that we want to spawn on the image. So first, grab some images to use as anchors or markers in real life, and we'll drag and drop them from the file system straight into Unity. Now I want to add them to a library. To do this, right-click in this window, then Create XR Reference Image Library. Hit Enter to keep the default name. With the library selected, in this window, the inspector, click Add Image. Drag in the image you want to use. I'll also tick Specify Size, and since 1 in Unity is 1 meter, I'll set these to 0.2 or 20 centimeters, and tick Keep Texture at Runtime. Now I'll do the same for another image. It's best to use JPEGs, which have lowercase names. You can have up to 1,000 images in your library, and an Android phone can track 20 at once. Now click on AR Session Origin and drag your reference library, which you've just created, into the slot here, so the app knows which images to look for. We'll set maximum number of moving images to 4, and now we need to find which virtual content to spawn. If you remember, our original robot was 1 meter tall, but the robot in our scene is only 10 centimeters, so we want to keep those changes. To do that, we'll save it as a separate robot. And to do that, it's very easy. You just drag the robot from this window into the project window and click Prefab Variant. Since it will appear on the image marker, we don't want another one floating in the air, so we'll delete this one from the hierarchy. Now just click on AR Session Origin and drag our new variant robot from here into the Tracked Image Prefab field. And we're done. Now we have to click Build and Run and put the app on the phone again, but since we've already done that once, I'll skip forward. And you can see now that our robot doesn't float in the air, but instead spawns on the image marker that we've added to our library. Of course, you can extend this to act in any way you want. You could add interaction. You could make 2 different characters or models appear on 2 different image markers and make them high five when the images get close together. You could also have a video that appears on top of a photo, so the photo appears to move. If you're an artist, you could use this technique to create AR art, where your own animation, saved out as a video, can appear on top of your painting or illustration. You could use it for education, activism, or awareness. The possibilities are truly endless. Now that was a demo of how to create a very simple AR application. But for more complex ones, like having the character interact with the environment in an intelligent way, It sometimes takes a very long time to build up that kind of functionality. Also, to test AR applications, you have to deploy them to your device and walk around a space. That takes up a lot of time, and it means you have to be on location to test it. For example, how can you test an app that's meant to work in a big room or a stadium or a museum if you only have a small studio? For these more complex use cases, we have a special solution called Unity Mars. It has tools and workflows that make it very easy to develop intelligent AR applications. It's built on top of AR Foundation, which means you get all of AR Foundation's benefits. It's multi-platform. You can build it once and put it on any mobile device. But it also has extra tools which speed up the process. To give you a quick peek into what Mars provides, one thing it has is the simulation view. This is a virtual world that lets you test your app without having to deploy it to your phone. These pictures are taken from the development of the Dr. Seuss ABC app by Sugar Creative, a UK digital content creation agency, and they used Mars to create that application. What you can see on the left is a simulated bedroom. This is one of many virtual environments that we provide in Mars, which lets you test your app right in the Unity editor. On the right, you can see the app in the real world. The real world view is a faithful reproduction of the predicted behavior in the virtual testing environment. So that massively reduces the time it takes to produce and test AR apps, which saves you time and money. It also means if you're creating an app for a huge environment, maybe a museum, but you don't actually have access to the site and you only have a small studio, you can still test the app in a reproduction of that environment without having to be on location. So now you have an understanding of Unity's different AR solutions, specifically AR Foundation and Mars, how AR is already being used to change the world, and exactly how to use AR Foundation so you can create your first AR app. So what's next? If you want to find out more about AR Foundation or Mars, you can visit the product pages. If you want to jump in and create more AR applications, I highly recommend the links shown on these slides. Unity Learn is a great resource with a huge amount of learning material available for free. And of course, there's a massive community out there, forums, and loads of tutorials and videos. So whether you're an artist, an activist, an engineer, or anybody who wants to change the world, I would urge you to download Unity, jump in, and start learning. Thank you so much for coming to the summit today, and in particular for coming to my talk. I really appreciate it, and I hope you found it helpful. I'll be doing a Q&A on the main stage at 11:35 EST or 4:35 BST. So if you have any questions, please do come join me there on the main stage and ask, or add me on Twitter or LinkedIn if you have any comments, feedback, or you just want to learn more. Thank you so much for joining me today. Good luck and have fun creating.